Good evening. Today I'm going to talk to you about successful failure. It's an experiment that we ran when I was at Volvo. And basically, it's just an account of all the lessons that we learn along the way. It's very infrastructure driven, and it's not for everyone. But I thought that it was a good topic to show like what's out there. So this is me. The slides are on this website. You can find them. There is links to interesting talks that are pretty funny, so I recommend you watch them. Let's see. Let's start with it's so hard to explain the problem. I have to start from so the next 5 slides is just like example of those things, and I'm just gonna ask your participation, like shout out, like what do you think is the output? Very good. Like I said, we start small. We start like very nicely, you know. But this is Bash, right? You understand? It's okay. Now you have something a little bit like what is remote and what is local. So you connect to SSH and you execute a command or a script, and you want to know what's the value. So the foo here is defined in the script. So it's going to show up here as foo because it's resolved locally. The other one, it's going to be resolved remotely. So that's how it's going to make sense, whatever. Just so you know, that's why you have the backslash in front of the, it's an escape sequence. And those kind of things is like, if you don't know, you're going to search for a long, well, not anymore. You can ask Claude, he will find out. But back when in the days, we had to do that manually. This is what we had to know. Little bit of Terraform, because, you know, why not? Do you know there's a bug in there? And you can spend a lot of time searching. But so basically, Terraform resolve. So this is a script. This is a here docs. This is a variable in Terraform, so it's going to get resolved. But this, it gets resolved locally, like when you apply, like when you run Terraform, not when the script starts. So the value is going to be hard-coded. You know, it's those kind of little details, and you're like, oh, you know, stupid me, of course. Why, how did I not know that? This one. So there is like people way smarter than me that have like, you need a website to explain to you how to do multi-line in YAML. This is not a joke. Like this is part of the talk. It's part of the experience. Just go on a journey. You know, like you're learning. This is, so you can do a bunch of stuff, and you can see like whether it's you know, the greater than or the pipe, it has different effect on the output. It's, you know, you get the picture. But then, you know, there's other caveat with YAML. It's a little bit, like, of course, you have the no way problem. Everybody knows that. It's funny, blah, blah, blah. But then, you know, many people use GitHub Action and, or like whatever. The CI is defined in YAML. And so they do something like this. So, you know, this is a Git short SHA. Maybe, oh. This, not what? I cannot zoom in, like, anyway. No, it doesn't like it. I tried. Just know it's a Git short SHA. So the short SHA, the thing is, with a SHA, it's like all the letters can be numbers. So basically, this gets evaluated as an integer, but you need to put the colon to make sure it's a string, otherwise the pipeline fail. And you would think that somebody would fix it, but no, they just create a new commit that doesn't have all numbers, so it gets implemented. So those are really interesting websites, and it's like, well, I like YAML. It's like, yeah, me too, for other people. You know, like, it's like, it works well enough, you know? It's not bad, it's just complicated. What do you notice about this API? So I'll give you, I don't want to, you know, burn you up. everything on the left side of the colon is fixed. That's how you design an API. This is a Kubernetes manifest or a snippet of it. This is how, because it makes it very easy to convert and to parse. Like that's the right design. Now, do you know why there is a parentheses on around this variable? So you define a variable called hello world, and here you have to put parentheses in there. Do you know why? Any guesses? Sorry?
To take it as a string? As a string?
No. Kind of.
You want it to resolve what you have in the shell that executes it.
This, thank you. Thank you very much. I'm so glad that somebody gets it. So because we call echo and not bash, this does not resolve. So when you're on your terminal, in your terminal, you type echo a variable, it's bash that actually substitute the variable with its value and then send it to echo. But if you're here, you have to tell Kubernetes to do it. So that's another way to, like the order of evaluation is something that is completely in your head that you have to remember. So this is a real production use case. So you have a volume to store data. You have init container, so it means it's a container that the application will run before the application starts. All it does is it writes some data to disk. It does a sync to make sure the data is committed. Then you have the second one that's going to run if this one succeeds. And it's going to check if the first part is written. Then if it is, it succeeds. Then you have the application. It's going to decode the part, one in B64 and one in hexadecimal, because why not? Then it's going to print hello world. This is real. Like, this is the kind of things that we have to deal with. It's full of stuff, full of food guns. If you're new to DevOps, welcome. This is it. Yeah, I like to be honest up front, so we can get to the good part later. So, where is Waldo? It's actually, there is a typo somewhere. Please find it.
You should ask those questions to Paul.
Yeah, that was like now, So why is this complicated? And why like, we've written a bit of code, right? We could write easily a unit test or something like, it's just text, why not? But the problem with those templates is that everybody wants them to be reusable, so you end up with an explosion, a combinatorial explosion of features and configs. And in the end, nobody can even understand what it's doing, because all the values, like the amount of possible manifest that gets executed with this template is just too much that nobody knows. And so what people do is they just try and say, let's deploy and see what happened in production. But I mean, like, am I far off? Like, am I the only one? It's like everybody can. So now, you don't have enough. Let's add a little bit more, because you want GitOps, right? You want Kustomize, because it's easy, it's simple, it's like, and add that Q, Jsonnet. By the way, I work with production systems that use those things. Like, I'm not making things up, or I'm not saying like, oh, look how funny it is. Every single one of those tools is pretty brilliant and great engineering. Like, there is real research behind those. But the combination of those, you get the picture of where the complexity comes from. And so, I'm a software engineer. I do infrastructure, but as a software engineer, I do a lot of cloud architecture, and I program also a lot. I do, like, how do I say? When people ask me, is it in production? It's like, my head, it means like, is it touching money? Like, if this goes down, is money being lost or not? That's just, or like the value that leads to money. So, why not you use just bash? Because, every problem can be broken down into some set of Unix command, like sed, orgs, like let's go, the whole world of infrastructure is running on bash already. Why not add a little bit more? And that's the status quo, right? This is kind of like, when you deal with infrastructure, it's not like good or bad, it's just like what it is. We have way too many layers of abstraction. We have way too many tools and specific tools. And the thing I hate most is like those domain-specific language. Like, please tell me how you decided to interpret bash, or like this Python subset, or like suddenly I have a new set of rules to learn, and it's like, it's just not possible. Now maybe, with Claude, it's like, as long as I don't have to see it, just make it work. But, and like, it's draining. Like, at some point you have to do some task, and it's gonna be like super hard, and you need to plan in advance your week, saying like, oh man, I hope nothing in my life just come and you have to plan. Please don't put a meeting in that time frame. Like, you really need to prepare, because if things goes wrong, it's not like you can leave and come back to it. You just have to fix it on the spot, and the time counts. So what is missing? Like, what really, if we had to design everything from scratch, and this is kind of the question that I've been annoying everybody about for the last like 7 years, day 2 operation is missing. It's like, hey, here's the hello world, just deploy it. And it's like, oh, look how easy it is. You just have to write some YAML. But it's like, man, have you worked in a company of more than, I don't know, 100 people? You have to do migration all the time. Like, if your company is more than 10 years old, you probably have several generations of the same product, just like still, and nobody can kill them. It's like, no, it's still used like by those people, in the basement, whatever. And it's like, but you have to come up with a solution. Like, suddenly they give you a tool, and that tool, to be able to do a migration, you have to come up with almost the same amount of energy that you would do if you didn't have the tool. So what's the point? On top of that, as I showed, you don't have like, you have to actually deploy it for it to work. And the reusability is super hard, because you end up with those massive templates and config and all those things. Also, that's more for Terraform. If you're playing a lot with infrastructure, it's like the feedback loop is just insanely slow. Like, 15 minutes is kind of a like good amount. I would be happy with that, but I've seen more. It's like, oh, it's like 8 o'clock. I start my day. Let's do a plan and then go and come back, or go to a meeting and come back. Authentication. So, is there a company here that is only in one cloud? No. We have none of that. None of that here, sir. We are serious people here. We don't do, as you can see. But it's like, have you ever tried to authenticate to Azure SSO to AWS? Like, was that a good experience? Would you like to? My question is, am I the only one that's crazy to think this is insane, And it's not like, the provider is not gonna cater to all our needs, It's like, yeah, it's your problem. Like, what do you want me to do? And I understand, I empathize with that. It's freaking hard. Authentication is the biggest lock-in of all, like cloud or not. And then you also have the apply and praise, like, yeah, the plan worked. And now the apply failed. What do you do? What's the problem? And so the thing is, the enforcing engineering practice, the same way we do with code, with unit test, with all that, is near impossible, because you have so many different language and parser. It's pretty hard. So we built a solution that we call Lingond. It's like 3 people. Jacob, that's like the super Terraform guy. Leonard, which was the PM at the time, and me. We just complain about everything. the goal was to be anti-abstraction. So you can read, I put the rationale there. Like I wrote this in like one go. It was ready. You know, it's like I explained very well why we end up. Forgot it was there. Don't you get it? Honestly, this is not meant to be funny. You know?
It's going without the Rangers.
So it's like, what do we do? Well, it's a library. It's not something. It's not a gonna solve everything. It's very specific to some use cases. It's like, well, here's the problem. We tried, like, we wanted to write infrastructure the way we write code. So we look at a bunch of projects. None of them could cater to the extremely weird use case we had. It's like, well, in a weekend, we just build a POC from the Friday. We come out on Monday with something, and we had something working. Like the idea was validated in our head. So you can convert with Lingon from Kubernetes. You can import them and directly convert them in Go. You don't have to do anything. Or once they're in Go and you refactor them and stuff, you can export them back to YAML or JSON. Terraform providers, well, basically the schema of the providers are embedded. So you can query Terraform JSON, like you get the schema of all the APIs that Terraform uses, and you can have that as Go. So it's auto-generated. And then once you write your Terraform code as Go, you can generate the HCL. So you can actually apply. I converted a bunch of L chart that you probably have in production. And honestly, it was so hard to read it in the template format. But in Go, when you refactor that, it was like, how did not see this, you know? And yeah, of course, there's a typo in the service account that is supposed to connect. And people have been complaining about that for months. And nobody could find out because there was template of template and, something very fancy. And it leads to a lot of security vulnerability that are in the production manifest. So why Go? And I tell you that this much is not about the language. Like, honestly, anything would, at this point, doing better was not really that hard. It was more about like the tooling, the fast compile time, the type inference, like all those things, all those details that when you program, you don't have to think about all those details. And so when people ask me like, well, but who is it for? Well, if you have to ask the question, probably not you. Seriously, it's like a very niche, because if you don't know that you have those problems, it's not going to solve them for you because you don't know you have them. But if you've been dealing with, there's 3 different kinds of companies, you can say that. Let's do an analogy of where people live. You have a village, which is like 100 people, maybe there's a bus going through there. There's more animals than humans sometimes. There's no hospital or anything, but hey, people live there. Then you have the city, which is like, okay, you have hospital, you have public transport, you have, a bunch of infrastructure that are available. And then you have like the mega city, London, New York, Tokyo. And all of 3 are just like place where people live, but the infrastructure they live on is just completely different. It's a different system. It should be called differently. And so this is where, like, if you're in the mega city kind of infrastructure, you're going to very much recognize those things. Most of people don't need it. That's why I'm not advertising for it. It's just like, hey, we did it. It worked well. Here are the lessons. And if you, of course, let's see, you probably have reached the point where you have too many Terraform providers, like what, GitHub, Slack, you keep adding them, your cloud, your on-prem, whatever. And you always have those use cases where you're always in a migration somewhere. So you cannot really do what you want. You have that timing. You have to plan your work in advance. Authentication is weird. You need to access that deprecated API that got removed, but you know, you're still running it and people are depending on it. And it's like, yeah. Or, and that's just my favorite, like not my favorite, but like the most common one is if your company is going to a reorg every 6 months, you're going to know why you need this, you know? and why 6 months is basically 2 quarters. And that's what, you know, the boss has for benchmark for his team. And if it doesn't match, well, he gets sacked and somebody else comes. Like, this time, let's do it right. And so if you can fit your whole infra in your head, like that's not for you. And if you just want, like for developer, it was that just had a 1 or 2 application. It was not, it was more hassle. Like YAML is fine. You know, like for those use cases, brilliant. You don't have to touch them often. You know, once they're set up, it's all fine. And truly, I didn't even want to put it like open source. I was like, no, this is for us. Like, who's going to care for that? And the feature team crawling is like, no, I was saying like no to almost everything. Let's create a website. Let's put some examples. It's like, no, if you know what you have, if you know what this is for, you don't need more explaining. And so that's a very like elitist kind of approach, but it's like, how many people have those problems? And of course, they all come with saying, oh, but my favorite tool, why don't you use that one? And I was like, okay, let's compare them. Let's be honest. Name a tool. I'm going to read. Like Terraform, Pulumi, which one?
Take Pulumi.
Pulumi.
We looked at Pulumi and it's a great tool, and it's true. Like, however, we found that the developer experience could be improved. A lot of arguments are raw strings and do not prevent us from writing invalid configuration. You have to pass the context all over. This puts us off. It's a global variable. We just have to pass the key everywhere. It's error prone, so like, but the support for Go was not that great, to be honest. The open source and hosted part isn't clear. It requires a token and an account. We could not find how to avoid that from their website, which doesn't build trust. So yeah, it works. And then you have like, oh, you have to pay per resources. And you're like, we cannot afford it. It costs more than the department. So we cannot use that. And so, no, but there is a way to do open source. It's like, where? Is that even legal? Can we do this? Is there a license? So, you know, we were like, okay, fine. Let's do it ourselves. You know, there is like Terraform is quite interesting because we use Terraform under the hood, but we don't write Terraform directly. We do it in Go. So yeah, here's the typical upgrade process, right? Migration process. Let everyone know that they won't be able to change anything for a while. Copy paste the resource to the code. Make the required change. Deploy the new resources. Migrate other resources dependent on the old one. Manually verifying everything works as expected. Pray that nobody optionally falling back to the old resource in case of an issue. Once fully migrated, remove the old resources. So that's the like, and people ask me like, why don't you use another tool? Because they don't support this. Like, this is my main use case. So everything is on the internet. Like, it's open. It's GitHub. You know, it's like, it's not like I'm hiding anything. So why, you know, was it a success? It's like kind of, but not really. It's like it worked. It worked beautifully. We had everything. We built a data platform in one month, and we had benchmark. We could measure which cloud was the best. Everything was kind of like abstracted. We had even our metrics were done in Go. So we could, when we changed something, we could automatically propagate where we already had a lot of experience with that. Like, for instance, most people don't measure the node pressure or the VM. So there is the ratio of like the full capacity versus how much is used. And it's like, yeah, sure, CPU, memory. So I want to see, I want to have one number that tell me like how likely is it to be full or fail. You know, that's just helps a lot. But culturally, it's really hard to like, we didn't advertise for it much.
it's not like we weren't hiding it, but it was more for us. So the lack of adoption and the difficult problem to explain, like, why did we create this? Because most people don't understand they have those problems. Like, this is day to day, like the migration process. This is like work. And also, well, it was kind of feature complete. I don't know what else we could have had. It's mainly like reading data, publishing and converting data. It was not like there was not much more that we could do. And it's very tempting to say, let's build one abstraction on top of that. Make it easier, make it simpler. It wouldn't have helped. Like, so many times I've had the tools that I know I could rebuild it because I know how it works under the hood, but I cannot change anything because they don't let me. But they want me to. It's like you drive a car and they give you like a little bike with like stabilizer.
Yeah.
And you're like, well, that's not going to go well. But the lesson from it is this. You always need an escape hatch. I'm not sure you understand what it means. Like, well, yeah, Terraform works great until you need that's one specific use case that just bugs you. And suddenly you have to resort to Bash or Python or, JavaScript, whatever. So you always need an escape hatch. Like, the same if you program in Go, sometimes you have to reach to C. Like, you cannot go further. And so you always need to get your hands dirty at some point. Hopefully never. But in case there is no other choice, you have to go one layer below. So you need that escape hatch. You have to understand what production means. Because an environment is just a name. Like, if the dev cluster fails, like, what happened? Like, is somebody on call? Should it be fixed? Because you can argue like, yeah, but it's not production because the customer keep getting served, but the developer are blocked. They cannot test, they cannot do anything. And so what's the cost really about having productivity cut? And so production means very different things to many different people. And one way we did was like, everything that is deployed is production. Like, if it's in code, it's production. If there has to be alerts, there have to be like there has to be a workflow for people to fix things. Monitoring is so much more important. I can tell you if a startup is going to be successful by how they set up their monitoring. And it's not about the tech, it's about what kind of value. If monitoring was the answer, what would be the question? And the question is this: are we making money now? Like, are we getting paid with this? And monitoring tells you yes, no. Like, that's the point. And from there, you can have very interesting, like, do you know how much of a customer request costs? Like, I read numbers for Uber many years ago was 14 cents. So one ride app that gets booked was actually 14 cents that it cost. And from there, like, a lot of decisions become clear. They went to the point where they even rebuilt a database from scratch because they understood they could save 10% on the bill for metrics. That's impressive, monitoring. CI speed is so important. I work on pipeline that lasts more than 2 hours, and it's like, you pray it doesn't fail, because this takes time. Like, you can spend a week fixing that. So monitoring speed, CI speed is really important. And also, do things manually first, because it's so easy to start coding, and then you realize I'm working on the wrong thing, but it's well implemented. Define what is an error. Like, oh, there's an error. And it's like, well, no, the program wrote error, but it's not an error. It's like, we expect it. We just can't change it. And those, it's like for the HTTP code, you have the 400, which is like, the progress form, or 500 is like, hey, we have a problem, we have to fix it. So depending on those two cases, you have to notify different people. I wrote a bunch of, inspiration. Maybe we have some time because they're quite funny.
47 minutes.
That's great video, guys.
Great stuff, Julian.
So this is DevOps. There are some. And this is what I feel like. Everything, like nothing fits. You have to do everything for yourself. And at some point, you don't have the mental space to write those bash set and all command that you want. The other talks are just as good. Like honestly, I highly recommend you have them a look. Give them a look. But thank you. And like everywhere, every time I do a talk, like I'm sorry if you had to maintain my code. I wrote way too much. But I hope you learn more by maintaining it than me by writing it. Thank you. Questions? Or we just talk directly?
Can't you tell what you're using it on? You used it in production, right?
Yeah. At Volvo Group.
So what did it do then? What did you use Lingo for?
We had to build a data platform, but
I mean,
actually an ML platform.
But you build set up servers, Kubernetes cluster, everything?
Yeah, from like basically when you have a big company, you acquire some startup or like some other company, and you have to integrate a lot. And I think we had like 3 teams before we could reach the team we needed. So there were so many layers, and every team has added their own layer on things. And we're like, can we please just focus on what we want, and then get the access, the approval, and make everybody happy. Once we have something we can show and demonstrate. And it worked. It was really, the problem is also when you're a big company, if you do something too good, you're going to step on the toes of other teams that are building something else. And so you're in the middle of a war. You don't even know why, because all you did was your job. And so it's not to say like we never imposed this on anyone. It was more like, hey, by the way, we did this. Here's a demo. Enjoy. I never had to coach anyone. We just put one simple example on the repo, which I'm not sure. So there was so we put that in the doc, and we said like this is the first, like this is the whole data platform. Like we use NATS. We had like it was an EKS. We had I don't even remember the name of the thing that does autoscaler. The carpenter, and now the code is probably outdated. But the nice thing is that we could easily update when an AWS API changed. We would update the provider, and like before even compiling, it was read in the editor, and we knew everywhere in the code base where we needed to update things, and that like you could revert, you could just prepare the change, do the thing. The second thing we did was actually a live migration for database. So we had a database. I think it was Grafana for the dashboard. And so we just put it read-only. We just took a backup, create a new instance, restore it, all that live, and all coded in, with unit tests, with everything. So it was really, really advanced. And that's like kind of a blew people. Like they could not believe this was real, basically, because that's what they want. Yeah, we had a lot of like discussion, and not everybody is keen on how to solve something. But when you say, yeah, we can do it, it's kind of a not everything is a technical problem. I leave it at that, But it was great, and the reason is like people left. Some people moved team, change, and so suddenly the project can lose traction like one day to the next. So yeah, that was a good lesson.
Can you show a little of the code?
Yeah. Yeah, there's plenty of that. Where we are. So CMD. So because we use I think it's this. Yeah, that's the global one. So we just had some parameter like what's the backend, the region, and the profile, and basically those 3 things. All the rest was like there is no config. You don't have to specify anything. It's just those 3 fields, and that gets like kind of a I don't want to say templated, but from there we could derive all the numbers and the thing we wanted for the use case we had. So this is the run. So first we create the VPC. And what we do is we generate the Terraform, we just apply it, and then we get the state back in JSON and we parse it. And so that meant that all the value that could be used after. Here, you can see like we get the cluster name, the VPC ID, the private subnet when you create the EKS cluster. And so we just have so fine-grained control of whatever we applied and when, and what could go in parallel and not. So it was a bit tedious for that, but that's what we needed. Then, we deploy Carpenter, but just the infra part, not the access to the cloud to do auto scaling. You set up a kube config so that you go fetch the secret and whatnot. You apply your CRD for all the monitoring that you want. You deploy the actual Carpenter now that all the IAM stuff is settled. Then you run kubectl. I can go on and on, but I think this is kind of like what it would look like. So we have some tags. Yeah, it's not really interesting. EKS. Yeah, you create new cluster, and we have a struct with all the options, and that will generate the Terraform, apply it, get the state, send it back. And so you have all the data. It's possible to automate that. That's all it does. And that's
cut down the state file running time.
Sorry,
because you mentioned it this way it can be faster, right? Because usually once you have the state file, you acquire it and you have the state of the whole infrastructure, and then it keeps it holding, and then checks what you are going to deploy. Then it can start to compare. That's why it takes a lot of time. It can take like 2 hours or something. Depends how much you have.
Yeah, this didn't let us write big state because the state splitting is really painful. So when you have a Terraform module that keeps growing and growing and you keep adding stuff because you need data from there, we didn't do that. We were very nimble with that. So the state just create the bare minimum, and all the other was just importing variable from other states that were resolved here. So it's not as the state could have changed in between, but we were okay with that because we knew the information we needed was not that reliant on the
only catching the deltas, maybe not the whole state file in that sense.
Yeah, exactly. So we parsed. You can look at it. It's everything is there. We haven't touched the project in a few years. Besides merging some, dependable PR, which that's why we are carve it because we didn't want to deal with that anymore. But yeah, there are some really fancy things you can do. Like for instance, we wanted to check on Kubernetes that the service account didn't have all the permission. So we just had a wrapper that you pass the service account that just checked that. And all of that was in code. We didn't need Lego or open policy or we removed actually so many tools from that because we could implement that which is not what I would recommend for most use cases. Again, this is just, I don't see another way to do it when you are in a situation where, the landscape of the infrastructure is just so fragmented.
Talking about the non-technical problems, usually the thing that I have seen when you implement the tools on top of the infrastructure, like Terraform, for example, is that then a debate start on how we should code, how we should restrict code. Did you face something like that when you were creating this?
We went pretty quick like this. We were building the platform while building the library. So we were using what we were dog fooding a lot. And there are some, at what point do you stop implementing a Terraform feature? Like the splat operator or this thing we had very big, or even in Kubernetes, what does it mean if a field? If you have just a colon but nothing, in some parser, it could be considered the value is null, but in someone they just ignore it. And so those are design decisions, and I'm more like, let's put an error first. Let's not be lenient about anything, and then gradually unlock the use case that, like, yeah, we have a concrete example of that works. Let's unlock this.
Should we continue the conversations in the lobby? Stretch the legs.
I'm about to faint.
Thank you very much.